Now what is called displacement reaction? Okay, displacement reaction is when a more reactive element removes another element which is less reactive from its compound. These reactions are named as displacement reaction. For example, AB plus C gives A plus CB. What is happening here? AB is one compound, C is another. C is more reactive. So what will happen? It will displace B from AB. So AB bond will break and AC new bond will form. Okay, so here what is happening? A is separated and CB is separated. Okay, so like that, any one which is more reactive will displace the less reactive elements. Okay, we can have with the example of here just ABCD we have seen. Now this is called reactivity series. In reactivity series, the elements which are here, see, it starts from the most reactive to the least reactive. The most reactive is potassium accordingly and least reactive is gold here. So potassium, sodium, lithium, calcium, more reactive. Then magnesium, aluminium, zinc, iron, tin, lead are comparatively lesser reactive. Then copper, mercury, gold, silver and gold, these are the less reactive. Below copper, elements are less reactive. Okay, so elements which are below hydrogen are lesser reactive, above hydrogen are more reactive according to reactivity series. It decreases this way, the most reactive to least reactive. Now we have one experiment here. We can see here two test tubes. We have taken ferrous sulfate and copper sulfate solution. We have taken two iron nails here. Iron nails are rubbed with the sandpaper. It will be made smooth and it will be tied with a thread. Let us see here. Take two iron nails and clean them by rubbing with sandpaper. Why we should rub with sandpaper? To make it uniform, and if any impurities or any other substances are stick with that, it will get clean. Take two test tubes marked as A and B. Each test tube take 10 ml copper sulfate solution. Okay, then tie iron nails with a thread and immerse them carefully in the copper sulfate solution. Okay, for about 20 minutes. Now in a test tube B. Test tube B, you are keeping iron nails for 20 minutes. You are observing it. What is happening? Compare the intensity of blue color. Copper sulfate solution is blue in color. So the intensity of blue color will start fading. Okay, and copper sulfate solution in test tubes A and B, and what will happen? We have to compare the iron nail color also. Iron nail color will also change. Okay, so compare the color of the iron nail dipped in copper sulfate solution which will kept aside. Okay, so what will happen? Iron nail color will also change, copper sulfate solution color will also change. Why? Because displacement reaction will take place. Here iron and copper, iron nails are taken in copper sulfate solution. Copper is less reactive than iron. So iron is more reactive, will displace copper from copper sulfate. Okay, and iron sulfate will form. That is why the nail color will change to dark brown and copper sulfate color will fade, because that ions are getting displaced here. Okay, so what will happen here? The iron nail become brownish in color and the blue color of copper sulfate also fades. Why blue color of copper sulfate fades? Because iron will displace copper. Iron is more reactive than copper. So the nail color also takes out from copper sulfate solution. You can observe the nail color is dark brown and copper sulfate color is faded. Okay, so why this is happening? Here you can see copper sulfate plus iron gives ferrous sulfate plus copper. So what is more reactive? This is more reactive. So this will displace copper from copper sulfate solution and bond will break here. Fe will combine with sulfate and you are getting FeSO4 and copper will convert into precipitate form here. Okay, so in this reaction iron has displaced or removed another element, copper, from copper sulfate solution. This reaction is only known as displacement reaction. We can see the reactivity series here where iron is present above copper. So iron is more reactive than copper. So iron can displace copper. Any element which is present here, if we write a reaction, will displace copper. from the solution of copper sulfate. Why? Because copper is less reactive compared to all these elements which is present above copper, okay, in reactivity series. Now here we can see another reaction where zinc and copper sulfate is there. So we are getting again copper is getting displaced by zinc. Zinc will displacing copper. Why? Because again in reactivity series, if we say zinc is more reactive than copper, so again zinc is displacing copper, and instead of copper sulfate now it has become zinc sulfate, okay, and copper is again converting into precipitate. Similarly, if we take lead from copper chloride, also lead chloride will form and again copper will precipitate. Why? Because again we will say the same thing, displacement reaction. Which is more reactive? Lead is more reactive than copper, so lead can displace copper. So any element which is present above copper in reactivity series can displace copper from its any salt solution, like this, okay. So here lead displaces copper, here zinc displaces copper, and previous experiment we have seen iron displaces copper. So 3 reactions we have studied, and all these 3, lead, zinc, iron, all the 3 elements are more reactive than copper, so they can displace copper from its salt solution, okay. This is only displacement reaction. So what is displacement reaction? The reaction of 2 components where more reactive element will displaces less reactive element from its solution, okay, and that is only called here displacement reaction. Like we have discussed in previous classes, we are around us always constantly there will be one or the other chemical reactions will be happening, like a digestion of food is also chemical reaction, respiration is also chemical reaction, photosynthesis is also chemical reaction. Apart from that, there are many other activities, knowingly or unknowingly it is happening around us, and they are part of chemical reactions. So how we can write it in the form of equation? When we know the formulas, when we know the symbols of elements, then symbols of elements can be made into a form of a compound. We can write a formula of a compound, and how that compounds reacts with each other, and what is new product is obtained, that is only called chemical equation. So chemical equation will have 2 parts. Left hand side always there will be reactant, and then there will be arrow, and next to arrow there will be product, okay. So right hand side is product, left hand side is always reactant. What are the conditions we maintain for the reaction, like a specific temperature, pressure, catalyst, or any other conditions has to be written only specifically on the arrow, okay. The components which takes part in the reaction should be written in the reactant side, and the whatever is obtained as a main product and side product should be written on the product side, right hand side. This is the part of equation. So previous classes we have discussed how to write a skeletal equation, how to write a equation with the formula. So like a description of any process in a big content can be summarized to a small equation and can be understood also, like a self-explanatory type of equations will come. So how to write a equation, how to balance a equation, what is the need of balancing a equation? Need of a balancing a equation, according to law of conservation of mass, matter can neither be created nor destroyed, but one form of matter can be always changed to another form of matter, okay. So that is why we have to equal number of reactant, how many parts of reactants is used in formation of a reaction, that many parts of product should be formed. So that will only be suitably saying as a law of conservation of mass, okay. Next we are seeing here the types of equations we have discussed in the previous classes. Like first type we have already discussed, that is combination reaction. Combination reaction is nothing else but it is a simple addition. Like in mathematics you have many numbers, you are adding it and always you are getting a single product. Like that a combination reaction also, here one or more than one reactants will combine and you always get a single product. That is called combination reaction, okay. Then we have discussed a second type of reaction, that is decomposition reaction. Decomposition means it is a reverse of combination reaction, where there will be one reactant and multiple products which will break into multiple products. So we have discussed 3 types of decomposition: in presence of heat, when the decomposition substance breaks, that is called thermal decomposition. In presence of sunlight, when substance breaks, that is called photolytic decomposition. In presence of electrical energy, when substance breaks, that is called electrolytic decomposition. So any kind of source of energy, either heat, electricity or light, any kind of source of energy is provided to the system. So that systems are endothermic reactions, where the heat is absorbed, heat is taken by the system to complete the reaction and the product is obtained. Okay, so all these type of reactions where single reactant and multiple products is called decomposition reaction. Then we have discussed about displacement reaction. Okay, displacement reaction means according to reactivity series. All of you are studying from the school level the reactivity series, like 6th or 7th standard science also has reactivity series. You would have studied the more reactive elements, it is in decreasing order. The more reactive elements will be kept at the top, like potassium, lithium, sodium will be more reactive elements, will be kept at the top. Then comparative, like that, slowly decreasing order. So lesser reactive, further lesser, and the least will be the less reactive or non-reactive kind of substances. So at the bottom it will be platinum. Platinum is the least reactive element. Okay, like that. Then above platinum you will see there will be gold, then silver, copper, like that. So you are observing it, the reactivity series starts from potassium, which is the most reactive element, and the platinum it ends, which is the least reactive. So according to reactivity series, in that reactivity series where the particular element is placed, the more reactive element will always displace the less reactive element. Okay, and like that the displacement reaction will take place. So from a compound, the more reactive element will take away the elemental part which is less reactive and form a product. That is only called displacement reaction. Okay, now double displacement reaction means here at a time what is happening, there are two components. The ion exchange will take place. From one type of ion will convert into another type of ion. They combine, the oppositely charged ions will combine and form a product. Like let's discuss what is double displacement reaction. For example, we have a reaction here where A plus B combines with C plus D and you are getting AD and CB. Okay, so AB and CD combines to give AD and CB. So what is happening? Now A is combining to D and C is combining to B. So interchange of valencies will take place. Okay, interchange of valency. Here this will combine to this and this will combine to this and you are getting a new product. Okay, so during double displacement reaction, an insoluble substance is formed known as precipitate. Okay, insoluble substance. We are writing in short form PPT. It is not PowerPoint, it is PPT, means precipitate. In chemistry, PPT short form is used for precipitate. Precipitate is the solid particles which is settled at the bottom due to gravitational force in a test tube or in any container where the experiment is going on. That is only called precipitate is obtained here. So now precipitate is obtained and supernatant solution. On top of precipitate there will be liquid, that is called supernatant solution. Okay, so there will be different parts. Now precipitate has obtained, that is only called double displacement reaction by interchange of valencies. Insoluble substance, precipitate will be solid particles which are not soluble in that component and they are settling down due to gravitational force. They are called precipitate. Okay, always in the reaction also, whenever there is a precipitate, it is indicated by downwards arrow. Downwards arrow indication is indicating a solid substances, solid particles which are settling at the bottom. Okay, so let's see that now how the reaction takes place. If we say A is positively charged and B is negatively charged, C is positively charged and D is negatively charged. So what will happen? A is combining to D. So opposite charges are attracting, positive with negative. Then this C is positive will combine with B minus. So like that AD and CB you are getting a product. So the reaction where the precipitate is formed by exchange of ions. Now positive and negative ions are getting exchanged, okay, between the reactants, and the examples of double displacement reaction. So now exchange of ions are taken place and you are getting a totally new product. In that product, one will be the main product, major product, and one will be the side product. The major product whose quantity and quality is better is called major product. Who is obtained in the lesser quantity is the minor product or the side product. Okay. So here when the solid particles are settling down due to gravitational force in the solution, they are called precipitate. So here you are getting a, by interchange of ions, precipitate is also obtained. That reactions are only called double displacement reaction. Okay. Let's see the next one. Now take about 3 ml of sodium sulfate. Let us know the formula for sodium sulfate, that is Na2SO4. All of you will be knowing the formula also, because we should know the formula, then only we can write the reaction. If you learn the symbols of elements, like we have discussed the periodic table, there is symbols for elements. Every day, wherever, I will suggest to all of you, wherever your study table is there, put one small copy of periodic table on top of it, and whenever you are free, you please observe that. So periodically what will happen, when you observe it many times, you will understand the symbols, you will learn that symbols automatically without learning. Sitting and learning 118 element symbol is not practically possible. So seeing that every day, you will automatically, it will get by hearted to you, learn to you. You can write a formula, you can write a reaction by yourself. Okay. So that is the easy method. Now sodium sulfate. Now what we have taken, take about 3 ml of sodium sulfate in a test tube. We have taken in another test tube, take 3 ml of barium chloride. What is the symbol for barium? Ba. What is the symbol for chloride? Cl. But interchange of valencies will be there. Ba will have 2 plus, Cl will have 1 minus charge. So by intervalency rule, the formula for barium chloride will be BaCl2. Here also interchange of valency rule is there. Na plus SO4 2 minus. So interchange of valency, that 2 minus will come here and 1 plus will go here. That is why Na2SO4, SO4 into 1. So that is SO4 only. So we are not indicating. Number 1 is not indicated. More than 1 numbers are indicated. So here BaCl2, Ba1Cl2, it will not be written, because whenever there is no number, it is 1. Understood? Okay. Like the charge also, when we write particular charges, ions, we have to show positive and negative. But if any problems or any answer is coming with the negative sign, we have to specifically mention negative sign. If answer is coming with the positive sign, no need to mention any sign there, because it is understood when there is no sign written, it is positive sign. Okay. So take a test tube. In that another test tube, we have taken barium chloride, mixed the 2 solution. What do you observe? What will happen? What we will observe when Na2SO4 combines with barium chloride? Now interchange of valency will happen. What will happen? Here we can say Na2SO4 plus barium chloride. Okay. We will try to write a reaction. Now I have told you, here there is a positive charge. This is positively charged entity. Okay. Now here what is the negatively charged entity? This is negatively charged entity. So they will combine. Now here this is positively charged and this is negatively charged. Okay. So this is 2 plus, this is 2 minus. This is 1 charge, 1 positive, 1 negative. So what we will write here? What will be the product here? Both are having 1 plus, 1 minus. So you will get NaCl. But Na2 and Cl2 is there. To balance that, we are writing 2 into NaCl. So 2 NaCl plus what is remaining? Ba2 plus and SO4 2 minus. So 2 plus 2 minus will get cancelled. What will be the formula? BaSO4, barium sulfate. Now what will be converting to precipitate? Barium sulfate precipitate will obtain. White color precipitate will obtain here. Okay. So are you able to understand what is happening? In one test tube sodium sulfate, another test tube barium chloride. When we mix together, we get white color PPT. White color PPT is barium sulfate PPT is obtained. Okay. So barium sulfate precipitate is obtained due to interchange of valencies. Okay. So let's see now what is happening. See, in one test tube containing, here what is been taken? Here barium chloride, BaCl2. Here what is taken? Here it is taken sodium sulfate. Okay. When barium chloride and sodium sulfate will combine, what are you getting? Okay. 1 minute. I'll write this side so it will not cross it. Fine. So barium sulfate. barium chloride and sodium sulfate, when they combine, when they mix together, this test tube is mixed into this. So what are you getting? This plus this, you are getting barium sulfate. So this white color precipitate is barium sulfate. Okay, are you getting? So here this solution is barium chloride, this solution is sodium sulfate. When both the solutions are mixed, you are getting precipitate of barium sulfate. Okay, now let's see here. You will observe that white substance which is insoluble in water, which is not soluble in water, otherwise you would have got a solution, that is solid crystals which are settling at the bottom due to gravity. Okay, so it means it is insoluble in water, is formed. This insoluble substance form is known as a precipitate. I have told you many times, again I will repeat, in chemistry a short form for precipitate is PPT. Okay, so precipitate is obtained. Any reaction that produces a precipitate can be called a precipitation reaction. So in this reaction precipitate is coming, so we will call it as precipitation reaction. Okay, let's see the next one. Now what is happening? Sodium sulfate reacts with barium chloride, you get barium sulfate and sodium chloride. How it is obtained? The opposite charges, the exchange of ions will happen here. The positive charge will combine with negative charge, so you are getting NaCl. There is Na2 and Cl2, so you are writing 2 NaCl. Okay, charges will get cancelled. Now Ba2 plus and SO4 2 minus. So what will happen? They combine, you get barium sulfate. Charges will get cancelled. You are getting barium sulfate. Okay. So which will be converting into precipitate? Barium sulfate will be in the form of precipitate. So arrow downwards will be indicated to make a precipitate. Okay. Next let's see sodium sulfate, barium chloride, you get barium sulfate and sodium. Test tube containing sodium sulfate, test tube containing barium chloride. When we mix both, we are getting a PPT of barium sulfate. Is it clear? This reaction is called double displacement. Why? Because both the reactants bonds are breaking and interchange of valencies are happening and totally two new products are obtained. Okay, like see here Na2SO4 bond will break. So Na will exchange with BaCl2 bond will also break. So Na will combine with Cl and Ba will combine with SO4, like that. So totally new two products are obtained. That is called double displacement. So two components at a time get displaced. That's what it is, double displacement. Precipitation is symbolized by an arrow pointing downwards. Okay, so arrow pointing downwards is a precipitate which is obtained here. Now we can say barium sulfate, we have seen like that, a new reactants, barium sulfide, BAS, barium sulfide combined to zinc sulfate. So what will happen? Again interchange of valency, positive to negative, positive to negative. So BaSO4 PPT and ZnS, that is zinc sulfide, is obtained. Similarly, one more example of double displacement. Here copper chloride CuCl2 plus potassium iodide to potassium iodide Ki. Again we will interchange the valency. What will happen? Cu will combine with I and K will combine with Cl. So what you are getting? CuI2 is a precipitate of cupric iodide. Cupric chloride will convert to cupric iodide and here potassium iodide will convert to potassium chloride. Okay, interchange of valence is happening. That is called double displacement. So at a time two components are getting displaced and one will be converting into solid crystals, that is precipitate, which is settling down at the bottom of the test tube. Discussed previously some reactions like chemical combination, where we have discussed how two or more components combine to give single product, like a simple addition in maths. Similar way, that is called chemical combination. Decomposition reaction, where the reactant is one and there will be multiple products, that is called decomposition. Decomposition, we have studied three type decomposition, means the breaking of a substance, degrading of a substance can happen in different ways in presence of heat, light or electricity. Okay, so different kind of decomposition we have studied. Then we have discussed displacement reactions in previous classes. So more reactive element will displace the less reactive element, that kind of reactions we have discussed. Then double displacement we have discussed, where the exchange of ions will take place, like bonds will break and the positive ions will get attracted to negative ion of other entity and bond will form like that, and negative ions of another entity will come to positive ions of the previous entity, and like that the breaking and making of bond will take place, and at a time two kind of changes will take place, that is called double displacement reactions. Now let's discuss oxidation and reduction reactions. These are very important reactions which is happening around us constantly in one or the other forms. Okay, so oxidation is addition of oxygen or loss of hydrogen is called oxidation. Okay, reduction is addition of hydrogen or loss of oxygen is called reduction. So let's discuss now what are these reactions. For example, we have an experiment here. In this there is a china dish. In that copper powder, which color is the copper powder? Just observe this. This copper powder color is reddish brown here. This powder is kept. Wire gauge has to be kept. Tripod stand is there. Tripod stand, the stand which has 3 legs, and why this wire gauge? A metallic mesh kind of gauge will be there. Why that has to be there? Because directly if flame is given, sometimes substance gets decomposed, substance gets degraded. So in between the mesh should be there. Heat, uniform heat should be given, and the small quantity of heat at a time should be given. So this is Bunsen burner. In presence of heat, when it is heated, heat a china dish containing 1 gram of copper powder. What will happen? Now copper is gaining oxygen to form copper oxide. Now first thing you observe here, what has happened? The surface of copper powder becomes coated with black color copper 2 oxide. Okay, we had reddish brown color substance, we have taken, on heating it turns black. Okay, why it has turned black? Because copper has converted on heating to copper oxide. Okay, now copper oxide, it is black in color. Now copper is gaining oxygen to form copper oxide. Now environment has oxygen, copper has gained that, and by heating what happened? It has, copper is gaining oxygen and copper is converting to copper oxide. So this is called gain of oxygen, or addition of oxygen is called oxidation. So copper is undergoing oxidation here. Okay. Now we can see here the black substance formed is because oxygen is added to copper and copper oxide is formed. Cu plus O2, CuO is obtained. CuO is copper oxide. So copper is gaining oxygen to form copper oxide. Okay. Now copper is gaining oxygen. So what we can say? We can say this process is called oxidation. Addition of oxygen or loss of hydrogen. So here hydrogen is not there. Right now copper plus oxygen, we have copper oxide. Okay. So we have, this process can be named as oxidation. Now see the reaction, 2Cu plus oxygen, you are getting 2CuO. What is this process called? This process is called oxidation. Why? Because addition of oxygen to copper is happening. Okay. So if hydrogen gas is passed over this heated material, copper oxide, the black coating on the surface turns brown again and reverse reaction takes place and copper is obtained. If copper oxide is treated with hydrogen, suppose the product obtained black color, if you pass a hydrogen, what will happen? Then again it will start turning, the black color will start turning brown and copper will be separating out. So reduction will take place. So reverse reaction is a reduction reaction will take place. Okay, but hydrogen should be added in that case. So if a substance gains oxygen during a reaction, it says to be oxidized. Okay, and if a substance loses oxygen during a reaction, it is said to be reduced. Okay, so substance gain to be oxygen, they are oxidized or reduced. So substances which are undergoing oxidation are getting reduced. Substances which are helping other substances to undergo oxidation, they are the reducing agents. Substances which are helping other substances to undergo oxidation, they are helping as reducing agent. Now let's see here what we have observed. Same, we have said reverse process. If the copper oxide, which black color copper oxide is formed, when hydrogen gases pass over it, copper is again separated. Okay, and oxygen is separated. Okay, oxygen in form of water. Now during this reaction, copper oxide is losing oxygen and is being reduced. So this is a reduction reaction because they are losing oxygen. Copper oxide is losing oxygen to hydrogen. Okay, so hydrogen can form H2O and copper is separating. So loss of oxygen is reduction and gain of oxygen is oxidation. Remember clearly. Okay. Then we have another thing, addition of hydrogen or loss of hydrogen. Okay. Now that also we will discuss. Let's see here. This is the reaction. CuO plus H2 gives Cu plus H2O. So what is happening now? Here CuO. Here O is given to hydrogen, okay, to form H2O, and what is happening? Cu is being separated. So now loss of oxygen is happening from CuO. So this process is called reduction. Okay. Now here what is happening? This hydrogen is being added with oxygen here. So this process is called oxidation. Okay. Addition of hydrogen, oxidation. Okay. Now we can see here the hydrogen is gaining oxygen and is being oxidized. In other words, other reactant gets oxidized while the other gets reduced during a reaction. Such reactions are called oxidation reduction reaction, or we can call it as redox. Redox word also have both the words included in this. Okay. So here RED for reduction, OX is for oxidation. So when we say redox reaction, simultaneously in the same reaction both the activities are happening. There is one component undergoing oxidation, another component undergoing reduction. So simultaneous oxidation and reduction is happening, is called redox reaction. Okay. Now zinc oxide plus carbon gives zinc plus carbon monoxide. Now see, in this reaction carbon is oxidized to CO and ZnO is reduced to Zn. Okay. So ZnO is reduced to Zn. This is one reaction, and carbon is oxidized to CO. So what is happening here? Addition of oxygen is happening. So this is oxidation. Okay. Here loss of oxygen is happening. So this is reduction. Are you getting? So addition of oxygen, oxidation, loss of oxygen, reduction, addition of hydrogen, reduction, loss of hydrogen, oxidation, opposite to that. Okay. Like this we are talking now another reaction. Here manganese oxide reacts with hydrochloric acid, gives manganese chloride, water and chlorine. In this process HCl is oxidized to chlorine. What is happening? HCl is oxidized to chlorine. Okay. This is called oxidation. Why this is called oxidation? Because HCl, there is a loss of hydrogen, okay, to convert it to Cl2. Then whereas MnO2 is reduced to MnCl2. MnO2 is reduced to MnCl2. Why? Because O2 is lost here from here. So O2 is lost means loss of oxygen is reduction. Okay. So simultaneously both the reactions are taking place. That is why it is called redox reaction. Okay. Getting it? What is redox reaction? Simultaneous oxidation and reduction is only called redox reaction. Okay. Let's see the next one. Now ethyl alcohol. Here C2H5OH is ethyl alcohol plus sodium gives sodium ethoxide C2H5ONA plus hydrogen gas is liberated. Now in this process if you study, you will observe the hydrogen is lost. Ethyl alcohol has lost hydrogen. Hence oxidation is gain of oxygen or loss of hydrogen. So what is happening here? Here ethyl alcohol is converting to sodium ethoxide by loss of hydrogen. So hydrogen is lost here. So this process is called oxidation. Clear it is? Next we will see reduction is the loss of oxygen or gain of hydrogen. Now we can see another reactions. C plus H2 gives CH4 or O3 gives O2 plus nascent oxygen. Nascent oxygen means very highly reactive atomic oxygen, which will be always written in bracket, that is called nascent oxygen, which will be used as a for oxidizing other substances. Okay, so now we can see here in first process what we have seen, there is hydrogen gain. This hydrogen is added to this carbon, and that is why you are getting CH4. So when hydrogen is added, what is it called? Reduction is loss of oxygen or gain of hydrogen. So this process is called reduction. Are you getting? Okay, then if you have here O3, O3 is losing oxygen, breaking it into this and this. Okay, so now what is there? Loss, oxygen is lost. Both the cases there is reduction. This is also reduction. So gain of hydrogen or loss of oxygen, both is comes under reduction. Okay, next we are discussing when oxidation and reduction takes place simultaneously in a given chemical reaction are known as redox reaction. Known as redox reaction. Okay, why? Because in this redox is RED for reduction and OX for oxidation. Okay, so this is making a word as redox. That's what this kind of reactions are called, redox reaction. Clear? Next we are seeing here iron nails are shown here. See both the type of nails. These are fresh nails and these are rusted nails. All of you would have observed rust. What is rusting? Rusting is whenever any iron article in presence of atmospheric moisture or moist air or water, when it comes in a contact, it starts undergoing rusting. Otherwise iron is a very strong metal, but when it undergoes rusting, it starts flaking out or it starts degrading, decomposing, and that will be reducing the strength of iron. That is why to prevent this corrosion, this is called corrosion. Corrosion is degrading of a substance of iron in presence of moist air, moisture or atmospheric water, anything like that. So in this condition it is converting into rust and it is degrading. To prevent this, sometimes the coating will be done, the painting will be paints will be coated, or any oily or greasy layer will be coated on iron articles, or it will be undergoing alloying. Alloying means mixing iron major percentage along with any other elements, and to give a new form of metal, that is called, new form of compound is called alloying. Alloying is mixture of two or more metals, okay, to make use of property like iron, stainless steel utensils all of you are using at home. Stainless steel major composition is iron only. Apart from that, cobalt, nickel is present. So it is, we can use the strength of iron as well as we can get rid of the disadvantages or the property which is called corrosion. Okay, so corrosion is degrading. Now what is this? The slow process of decay or destruction of metal due to the effect of air, moisture, acids on it is known as corrosion. This is called corrosion. Corrosion is example, rusting of iron is one of the example, like tarnishing of silver articles turns dark black color, that is also called corrosion, or copper articles turns green color, that is also called corrosion. So corrosion is in presence of atmospheric condition when degrading of a substance, a slow process due to effect of moisture. Here also simultaneous oxidation and reduction happens in corrosion, and that is why it is called electrochemical process. So due to effect of moisture, layer of reddish brown color is deposited over surface. It is called rust. What is the formula for rust? Fe2O3 H2O is rust. Okay, now what is corrosion? The iron articles are shiny when new but get coated with reddish brown powder when left for some time. This process is commonly known as rusting of iron. Okay, now when a metal is attacked by substance around it such as moisture, acid, it is said to be corrode at this process, and it is called corrosion. Okay, the black coating on silver and green coating on copper is also other examples of corrosion. There is a tailing of mercury is also corrosion. There are many other examples. Lead is also undergoing corrosion. Okay, so corrosion causes damage to car bodies, where the rusting happens. Bridge also undergoes rusting. The iron part, the iron rods will undergo rusting and bridge will collapse. Iron railings, ships will also undergoing corrosion, because the bottom part of the ship, which is made to carry more substances made with iron, that will undergo corrosion when it is in directly contact with water always. And the sea water, generally ships will be in the sea, and sea water is highly salty water, so salty water is acting as an electrolyte. Corrosion will accelerate in that process. Okay, so especially those of iron, corrosion of iron is a serious problem. Every year enormous amount of money spent to repair or replace damaged iron articles. Okay, so we can do it. Have you ever tested or smelt a fatty oil containing food material? We will just see here how we can prevent. Okay, then we will go ahead. So prevention can be done by oiling, painting, by surface with oiling or painting, or we can do it with alloying, converting into a alloy, or we can do it cathodic protection. We can make it any other metal as cathode, and we can make it iron will be so first that metal will come in contact with atmospheric conditions, so iron will be protected. Okay, then galvanizing is any iron article will be dipped in like zinc, and the coating of that iron will be, that metal will be happening, and because of that it will be prevented from corrosion. So this can be to prevent corrosion. Okay, corrosion means rusting. We are talking here this in terms of rusting. Okay, now another type is there when oil or fat. At home level you would have seen any butter is kept or any kind of fat is kept just left outside without refrigerator. So 2 or 3 days if it is left outside, it will start turning color. First it will be white color, then it will turn yellowish, and then it will be further darker yellow, and the smell will also start coming. One foul smell will start coming. That is called spoiling of oil or fat. In presence of atmospheric condition, it undergoes oxidation, atmospheric air. So due to oxidation, that is foul smell is generated. That is called rancidity. So substance will convert into a rancid substance, which is spoiled substance, which is converting into a poisonous substance which should not be consumed. Okay, so the marketed products which you take butter from the market, it will be in the shelf in the shops, it will be for months together, and it will not change its color or it will not change its smell also. Why it happens? Because they add antioxidants. Antioxidants are the substances which will prevent oxidation in that substance. Okay, so now we can see, have you ever tested or smelt a fat or oil containing food material left for a long time? That is, when fats or oil are oxidized, they become rancid. Rancid means a foul smell is generated due to oxidation, and their smell and taste changes. Usually substance which prevents oxidation are called antioxidants. Antioxidants are added in any fatty or oily substances. So to food containing fats and oil. Keeping food in airtight containers helps to slow down the oxidation process, because airtight container, air will not enter. Air is having oxygen, so oxygen will not enter, means oxidation can be prevented at some level, but it will not be permanently in airtight container. Whenever you are eating it, you are opening it, so you are allowing oxygen to go inside. So only we can say the process is slower. Process is not stopped completely. It will be stopped completely if you never open that box, correct, like that. So the chips manufacturers usually flush bags of chips with gases such as nitrogen gas. All of you would have seen a bag looks like a chips packet. It looks very big, and when you puncture it or when you open it, there will be very few chips inside. Why? Because the nitrogen atmosphere it is kept, so it will be preventing oxidation. Okay, so to prevent the chips from getting oxidized. When it gets oxidized, it will start smelling and it will change the color appearance also. Okay, and you will not eat it. Marketed value will be reduced. Now similarly we can talk copper articles also. You can see this is copper pipe. In presence of moisture and carbon dioxide in the environment, that is started turning a green color coating on it. That is basic copper carbonate. This coating is called basic copper carbonate. What is this coating? This is another type of corrosion. Corrosion of copper. Like corrosion of iron, we have seen rusting. Like that, corrosion of copper due to formation of basic copper carbonate. So copper objects gets coated with a green substance called copper carbonate with passage of time. Okay, then this green substance is formed due to reaction of copper with carbon dioxide and moisture present in the atmosphere. So this is also another type of corrosion. This is also another type of corrosion. Okay, then we can see one more example. All of you know the silver articles which you are using at home. So that silver articles periodically, if it is not cleaned, it will start turning black. This is called tarnishing of silver. Okay, what is it called? Tarnishing of silver. Tarnishing of silver is also due to, this is also a type of corrosion. Okay, example of corrosion only. Okay, why it is happening? Silver objects becomes blackened and lose their shining with the time. Why it happens? Due to reaction of silver with hydrogen sulfide. In atmosphere there is H2S gas. With that, when it reacts, the articles will start turning black. Okay, it can be cleaned with any kind of acidic substance, but it will be turning black with time because of the substances when it reacts with hydrogen sulfide gas. Okay, so this is called tarnishing of silver. Okay, like this, if you say when oils and fats are oxidized and even allowed to stand for a long time, they become rancid. Okay, so rancidity is the smell and the taste and the appearance of the oil and fatty substance changes with time due to presence of oxygen in the environment. It undergoes oxidation, that is called rancidity. Okay, rancidity can be two types. One is called hydrolytic rancidity and one is called oxidative rancidity. Okay, so when substance undergoes hydrolysis, oils and fat substances undergoes hydrolysis. When oils and fats undergoes oxidation. So there are two types of rancidity. In both the cases, the substance will get spoiled due to having a texture, appearance and smell will change. Okay, now to prevent rancidity, what should be done? Food is placed in an airtight container. It can be placed. Then chips are stored in nitrogen, as nitrogen is least reactive. So it will be company only made that way. It will be filled and then packed. Okay. Then antioxidants are used to prevent oxidation of food containing fats and oils. So marketed products will have heavily filled with antioxidants. Then foods are also stored in refrigerator at low temperature, reduce the rate of reaction. Okay, so refrigeration is also one of the prevention. Then we have advised to store food away from sunlight. Why? Because sunlight also can increase the rate of reaction. In presence of sunlight, the solar energy is given and the rate of reaction will increase. Okay, so you have to keep away from